For our next video, we're going to look at dividing polynomials. Now, again, we've split it up into three different ways by a monomial, long division, or synthetic division. For this first one, we are just going to be looking at monomials, or at least at first, we're going to look at how to divide just by monomials. When you are dividing a polynomial by a monomial, you're going to split up the numerator into individual pieces, each one over the denominator, then cancel. Now remember that denominator, or the divisor, will be a monomial. So, for example, if this dividend is a polynomial, 2x to the fourth minus 8x cubed plus 12x squared minus 6x plus 2, this one we call the dividend. You divide by the divisor, so divided by 2x. We will put the dividend on top as a numerator, and we'll put the divisor on bottom as the denominator. So all of this divided by this one. Again, notice this is a 5-term polynomial divided by a 1-term polynomial, or a monomial. I can take my 5-term polynomial and divide it by a 1-term polynomial by splitting each piece up separately. So 2x to the fourth over 2x, 8x cubed over 2x, 12x squared over 2x, 6x over 2x, and 2 over 2x. Notice that I didn't forget this negative, positive, negative, positive. Those go right here in between each individual fraction. So now that I have each one over that denominator, now I just kind of match things up and cancel. These 2's will cancel. This x cancels with one of these and leaves 3. 8 and 2 will cancel, leaving a 4. This x cancels with one of these, leaving 2. 2 and 12 make a 6. This x cancels with one of those, leaving 1. 2 and 6 make a 3. X cancels out with x. 2 and 2 cancel out, leaving just a 1 on top. Now this x on bottom does not cancel out, so it needs to stay as a fraction 1 over x. So when we look at our simplified version, I'm going to get... So 1 over 1 is just a coefficient of 1, x cubed. That's my first term. 4x squared, and these are all canceled out, so minus 4x squared. That goes right here. Plus, again, this all canceled out, 6x to the 1, or just 6x, minus 3, and everything else canceled out, so minus 3, plus 1 over x, 1 over x. So again, this polynomial divided by this monomial left this. This is what we ended up with in the end. Okay, now again, that whole process is basically the same for any time you are dividing a regular polynomial by a monomial. You're just going to put these all on top, this one on bottom, cancel top and bottom throughout. In the end, notice you might not be left with just a constant. You might be left with something over a certain value of x. That's all right to get it like that. Moving on to dividing polynomials using long division. We're going to use our long division algorithm, or again, that long division process like we do with whole numbers. Now, this one will work when we're dividing by things other than monomials. So if you're just dividing by a monomial like this, go ahead and do this process. That'll work for you. When you are dividing by things other than monomials, so like binomials, trinomials, or any other number of terms, use this long division process. Note, you need to make sure to add a digit or a place value for each degree of term, even if there isn't one. And I'll show you an example of what I mean by that. Basically what I'm saying is, like in this example where we have x squared, that's a degree 2, and just an x, that's a degree 1. If we didn't have an x, we should write in 0x. You want to make sure there is a spot, a place value, or a digit for each one. In the end, just like with our long division algorithm for whole numbers, if you have a remainder, add it to the end as the remainder over the divisor. That'll become your last term. So, when you have a long division problem, it might be written a couple different ways. You'll see it written like this a lot, this polynomial divided by this polynomial. Okay, this is a clear indication that here is your dividend divided by here's your divisor. Now the same dividend and divisor can be written this way. Dividend on top over divisor on bottom. Again, that's like numerator and denominator if we think of this as a fraction. This again is saying this divided by this. Lastly, you might see it this way. This to the power of -1. A -1 power brings it to the bottom. So basically this is saying this guy needs to go down here and we can get rid of that. Notice how this looks exactly like this. X squared plus 3x minus 10 over x plus 5. Okay, and of course that negative power would no longer be there once it comes down. So 3 different ways to read or spell out a division problem. So let's look at what the long division algorithm will look like. We're going to use those exact same ones from the previous slide as our example. X squared plus 3x minus 10 divided by x plus 5. We're going to write this inside of our division box. This is our dividend. It goes underneath. Our divisor, x plus 5, goes on the outside of the box. So this is what our problem should look like. Now, we don't need to look at this x plus, or the plus 5 part. We're mainly just concerned with this front term, just x. X is going to go into each of these digits. We're going to start by looking at the first one. X goes into x squared how many times? Or again, you're thinking, what times x would make x squared? Well, that would come out to be x, because x times x is x squared. So, x goes into x squared x many times. X times x makes x squared. X times positive 5 is plus 5x. Now remember, with your division algorithm, the next step you're going to do is say minus this whole thing. And remember, from subtracting polynomials, minusing this polynomial, you distribute that subtract to each piece separately. So what I'm going to do, get rid of those. I'm going to move this guy out of the way to make room for the negative version. Right? All I did was the negative of each of these. Opposite here, opposite here. We can actually just get rid of those so it's not so cluttered. So I'm subtracting this now. X squared minus x squared. I'm just going to put a money symbol there because it cancels out. Every single time, as long as you do this correct, this first term should cancel out. If you want to put a 0, that's okay. I wouldn't use an x because we're using the variable x. So just some symbol to say this has canceled out. Always will. Now positive 3x minus 5x will become a negative 2x. And you can't forget we need to drop down this negative 10. Now we do the same thing. X goes into negative 2x how many times? Well, that would come out to a negative 2 because negative 2 times x makes negative 2x. So when I do that multiplication, I get negative 2 times x is negative 2x. Negative 2 times positive 5 is negative 10. Again, like before, remember, I am subtracting this entire polynomial. This thing minus this thing. To do that, get rid of these. I actually need to change those signs from negative and negative to positive and positive. So I'm going to get rid of that, replace it with this one. Now, when I do negative 2x plus 2x, again, that should cancel out. So I'm using the money symbol again. Negative 10 plus 10, I have a remainder of 0. If you have a remainder of 0, you don't even really need to mention it. You can just say, all right here is my answer. X squared plus 3x minus 10 divided by x plus 5 will give me an answer of x minus 2. That would be my quotient. Let's do another long division. Now this one is going to get a little bit goofy. Notice here I have an x to the fourth and x to the third, but no x squared. That's why when I wrote it down here, I had to put in my 0x squared. This will cover my extra digit or my extra term. Okay. Now again, this one is a little bit longer. There are 4 terms here, which technically means 5 because of our hidden 0. And then this one, notice that there are again 2 terms. This one has a coefficient of 5. That's going to play an important piece because it's now 5x goes into each piece. So looking at this, 5x goes into 5x to the fourth. How many times? It goes in x cubed number of times. Okay, again, what that means is 5x times x cubed is what would give me 5x to the fourth. So in fact, when I do x cubed times 5x, it becomes 5x to the fourth. X cubed times 2 becomes 2x cubed. I have to do this times both pieces to get this. I need to make sure this number up here times my first term will come out to this one exactly. Again, one of the reasons why we need this to come out exact is because we want these to cancel every single time. Now since I'm subtracting this red one, I need the opposite signs. So again, oops, I'm going to go like this. I want the opposite version, so I'm going to get rid of that and put in my 2 opposites, a negative 5x to the fourth and minus 2x cubed. This way, when I subtract them or combine them here, these will always cancel out. So I put my money symbol. 2x cubed minus 2x cubed came out to a 0x cubed, and I always have to bring down the next term. Now notice, 5x does not go into x cubed. It's like I have a 0x squared there. So I could go through the process of multiplying this times each one and putting my zeros. They would subtract to get 0. Or, to keep things a little bit easier, I can just drop down my 15x and start from there. Now, because this one happened to be another 0, I now have to go 5x into 0x squared, 0x times. Now, I only put in these x squared and x's because I know that those are the next degree. X to the 3, x to the 2, x to the 1. Now again, I could go 0 times the 5x and put 0 here and 0 here. But since I know it's just going to come out to the same thing anyway, I'm just going to jump the gun and drop my 6 right away. Now, I can just say 5x goes into 15x 3 times. And 3 times 5x makes 15x. 3 times 2 makes the 6. Okay, kind of sped up my process there just by getting rid of everything. So at this point, again, I'm going to be subtracting these things. So I need the opposite of these two. Oops, didn't mean to get rid of that. Meant to get rid of the box. Get rid of this. I'm turning those each opposite of what they were. That way, when I go 15x minus 15x, that's going to cancel out. Put in my money symbol. Positive 6 minus 6 becomes 0. So I have no remainder. I don't have to put anything up here. So in the end, technically, this is my answer. X cubed plus 0x squared plus 0x plus 3. Now again, had a 0 here. I needed to mention that just so that my work all panned out. Now that I have 0x squared and 0x though, I don't really need to include those in my answer. The only things I need are my x cubed and my 3, so we would say that the end answer is actually just x cubed plus 3. We're going to do another one with long division. Again, this one's going to get a little bit longer, but I do want you to be able to see that even with these more term polynomials, you're still doing the same exact process, just going one at a time. So this long polynomial on top divided by this one on bottom. I rewrite it so that this divisor, or the denominator, is on the outside. This dividend, or the numerator, is underneath the box. So now I start by saying 2x cubed goes into 2x to the fifth x squared number of times. Now when I go x squared times each of these terms, this would be the polynomial that I get. This piece times each one of these. Again, I don't want to use this. I need to use the opposite because I'm doing this minus this polynomial. So I get rid of it, and I put in the opposite version of it. Okay, all I did was distribute that minus to each piece separately, and this is what it'll come out to. Remember, these two should always cancel, so I put the money symbol. 7x to the fourth minus 1x to the fourth is 6x to the fourth. These two make 11, these two make 5, and I can't forget to bring down my negative 34x. Now I'm looking 2x cubed into 6x to the fourth. Well, that's going to go in 3x number of times. 3x times each one of these will give me my next polynomial on bottom. And again, the reason I'm using 3x is because 3x times 2x cubed is what's going to become exactly 6x to the fourth. Now again, because I'm subtracting this on bottom from this on top, I don't want to use this version of them. I want the opposite of each one. So I want to make sure this thing, I have the opposite of each one over here. So negative, 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 positive. We'll just replace that like so. All of the negatives and this one. So they're all opposite. Now again, these two will cancel out. Put my money symbol there. These two add up to a negative 14x cubed. These two become negative 7x squared. These two become negative 28x. And I can't forget to drop down this 14. Okay. Now I need to look at 2x cubed into negative 14x cubed. So what times 2x cubed would make negative 14x cubed? I would need a negative 7. So now when I do negative 7 times each one of these pieces, that'll give me my next polynomial down here. So in fact, that gives me negative 14x cubed minus 7x squared minus 28x plus 14. Again, we don't want this version of it. We are subtracting. I'm going to go like this. This whole thing is being subtracted. So since it's this minus this whole thing, we're going to get rid of this and put in the opposite version. That way, again, these two have to cancel out. I'm using the money symbol there. These two become 0, these two become 0, these two become 0. That tells me that there is no remainder left over here. So this long polynomial divided by this one will come out to x squared plus 3x minus 7. Or again, you can write it all as 1, x squared plus 3x minus 7. We're going to do one more with this long division. The reason I use this one is this is very similar to the first one that we did. I'm only changing this piece to be a little bit bigger. That way we do end up with a remainder. I know we've gone over ones that didn't have a remainder so far, and I just wanted to show you one that does have a remainder. So I put this dividend underneath the box, divisor outside. X into x squared, x many times. X times each of these becomes x squared plus 5x. Again, I don't want to use this version. I want the opposite. So I change each of those to be a negative. That way, when I combine these two will cancel. These two become negative 2x. And I need to drop down this negative 13. X goes into negative 2x, negative 2 times negative 2 times each of these becomes negative 2x minus 10. Again, I don't want to use this one. I'm subtracting it, so I want the opposite of it. So those will turn the exact opposite of what they were. These two should always cancel out. Oops, wrong button. Here we go. Sorry about that. These two will cancel out. Money symbol. These two, negative 13 plus 10 becomes a negative 3. That tells me that negative 3 is going to be my remainder. Because I already have a constant, this last piece has to be my remainder. So how do I show that? I go plus my remainder, negative 3, over this divisor, x plus 5. So negative 3 over x plus 5. When you write it out, you can either say x minus 2 plus negative 3 over x plus 5, or because this is negative, I can pull that out and say x minus 2 minus x over x plus 5. Notice that this negative just took place of this plus, call it a minus. But otherwise, that would be how to get your end polynomial. That'll cover it for video 2. In this video, we discussed dividing polynomials by monomials and dividing using long division. In the next video, we will look at using synthetic division.